If you've ever developed a Kubernetes application for production systems, you know that setting up a local development environment for that application is hard. Just setting up an IDE or code editor isn't good enough. You need to have a variety of tools and configurations on your system in just the right way. Otherwise, you cannot develop and test your application on your local system. And setting up and managing all this tooling is not exactly time well spent, right? So in this video, I'm going to show you a much faster way to develop your Kubernetes applications locally using a tool called Mirror. This tool lets you test your changes locally right after you make them without having to go through a CI/CD pipeline or having to deploy your changes to a test environment. So let's get started. Now, modern applications cannot be built in isolation. You cannot just git clone a code base, fire up a command, and expect the app to run flawlessly on your computer. These apps are usually part of a much larger system. Let's say you want to develop service A, which is the main service that all your users interact with. This one right here, right? Service A might be talking to some database like MySQL to get some data or put some data. It might also be relying on the functionality of some other microservices like B and C, right? But B in turn might be talking to another microservice like D and might also be picking up some data from some Kafka topic to do its job. Similarly, C might also be talking to some sort of a caching server like Redis or maybe some other components in the microservice architecture. So when you make a request, when a user makes a request to service A, this request actually travels through all these microservices, this entire system, and finally produces a response in service A and sends it back to the user. Now, say you made some code changes to service A. In order to properly run and test your code changes on service A on your computer, you're going to have to deploy this entire system locally because everything depends on everything else. And sure, technically you can do that. You can use tools like Docker Compose and run all the containers on your computer, or you could even run a Minikube cluster and then use a bunch of manifests to deploy the whole system on your local. You can do that. And sure, maybe then service A might properly run on your computer. But running such a system on your local is not a one-time task. This requires constant maintenance over time. If there is a new version to one of the dependencies, you've got to update your images too. Unless that upgrade breaks something in your local, in which case you're going to have to revert or make more changes to adapt to this change. If there was a database schema migration performed on the remote application, then you also need to perform these migrations locally to keep in sync. If your code needs some dummy data to work with properly, you need to arrange for this dummy data. You need to load it either from a production or staging environment, or you need to create your own fake data to work with. Then there's tooling issues. Maybe Docker is misbehaving on your Mac or Windows because of some networking issues or some configuration issues, VM configuration issues. And now you've got to deal with those problems. And at this point, you realize that you're far away from dealing with problems that you should actually be dealing with, which is your application itself. The point is, the amount of time you spend just maintaining your local setup for such a system could have been better spent on things that actually matter, which is developing the application itself. Not to mention that this kind of a setup will also probably blow up your computer for resources. So what are the alternatives? How is the industry solving this problem today? Let's see. One way is to use production-like environments. These are often called staging or pre-prod environments. And the idea is that the entire application is deployed to these environments exactly how it's deployed in production, except this environment won't serve any production traffic. Rather, it's meant for testing purposes. So if you have a staging environment, you don't need to test anything locally. You could just deploy your app to the staging environment and test things out reliably without breaking production. The problem is you're not the only person testing your application on staging. You're not the only developer in the company, right? There are other developers who also want to test their applications, who also want to test their code changes, and that will happen in staging as well. So for example, if you're testing application A, your code changes, and this guy right here also wants to test, then probably there's going to be some sort of interference, some sort of conflicts, right? Because if you deploy and then this guy deploys, then your changes disappear. So either their testing will interfere with yours, or you're going to have to wait in line for other people to finish their testing so that you can exclusively grab a lock on the staging and then test your applications. And now the whole process of testing your changes takes a lot longer, right? Even if you have a very small code change that you'd like to test, you're going to have to push it to Git. From there, you're going to have to push it to CI/CD pipeline. And after your test goes through CI/CD pipeline, it will land in staging, and that's when you get your test. And if at this point you realize that you probably made a small typo or some code needed to be changed just a little bit, it can cause a lot of frustration because you're going to have to go through this entire cycle all over again. Not a happy scenario. So maybe you could have multiple staging environments. Why just one, right? So maybe you could deploy multiple test environments or hell even per user environment. So one staging environment for each developer. The problem with such environments is that these are also very expensive to set up and complex to operate. So these are probably an operational nightmare for your DevOps team and will also cost your company a lot of money. So chances are that your DevOps team will make a lot of compromises in such setups. So even if you have multiple staging clusters, they probably won't reflect what is actually in production because these are much miniature versions of them. Then how can you test your application reliably on such environments? And so what is even the point of having these staging environments if they don't reflect production? This is where Mirror-D introduces a new way of developing applications. Mirror-D is a tool that lets you run your application locally without having to run all its dependencies too. This is because it runs your local app in the context of a Kubernetes pod. What does that mean? It means you use Mirror-D to run Service A locally on your computer. But Mirror-D runs Service A as if it were running inside the Kubernetes pod, which is also running the actual Service A staging. This way, your Service A has access to all its dependencies. And so now, as a user, when you make a request to Service A on your local machine, this request can actually travel through all these dependencies because Service A has access to them. And finally, a response can get returned back to you. And because your Service A is running in a pod, it is also able to access things like environment variable, file system, the network namespace, and even perform things like DNS resolution, just the way the staging app is able to do them. Internally, when you run your app on your computer, Mirror-D intercepts all the system calls it makes. This means any calls to access the network, the file system, and other services provided by the operating system. Then Mirror-D proxies all these system calls to the remote pod, which actually serves them. This makes your app think that it is running inside the pod. Smart, right? So now you can indeed just git clone a code base, make your code changes, and test the app directly on your machine without having to go through CI/CD or interfering with other developers' testing. This development environment is much faster, cheaper, and easier to set up. Your local dev environment is a lot less complex now, and everyone can test their changes using the same staging environment without causing conflicts. Let's try this out. So Mirror-D supports all the major platforms. You can install it based on whichever platform you're using. You can use it either as a command line tool, or you can also integrate it into your code editor or like IDE, whichever you're using. Also make sure to configure your kube control CLI to be pointing to your staging cluster. The staging cluster is the cluster where all your microservices are already deployed. Now let me show you the microservice system that's running on my staging cluster. There are 4 main components running in my staging cluster: Service A, Service B, Redis, and MySQL. Service A and B are just 2 very simple REST APIs that I wrote in Python and Flask. I use these technologies for this demo, but in general, Mirror-D works with any programming language and any technology, so you don't need to worry about any restrictions. Now, A is the main user-facing service, and it exposes an API called complex request. Here are my services. As you can see, A is a very small and simple Flask API. The only route it has is complex request. When a user makes a request to complex request, Service A does a couple of things, right? A couple of steps it takes. The first step is that it goes to Redis to try and fetch some data. You can see the code. It tries to fetch the value of foo. It's just a random variable, nothing else. Next, Service A will also try to reach out to B on the /data API and try to get some data back from it. /data, get some data, get it back as a response. Now, after getting these 2 data points, Service A goes on to do some more things, right? It tries to read the value of an environment variable called host. And of course, the value of host will depend on what kind of host this service is running on. If the host is running on staging, it will have a different value. If it's running on the local, it will have a different value. Finally, A also tries to read some data from a TXT file which resides on the local disk. And once A has all of this data, it compiles all of this data into a JSON object and returns it back as a response to the user. So A fetches data from Redis, fetches data from service B, gives it back to the user. Now, one more detail here. What does service B do when it receives a request from A on the slash data, right? Service B also in turn has more communication. So B reaches out to its MySQL database to get some data. And once it gets the data, it returns it back to A. So let's see B's code base. Here. So B is also a very simple Flask application. It has only one controller, which is slash data, one API route. And when it gets the request, it will connect to the database, just make a simple select request to get all the data from the table, and then give it back as a JSON object. That's it. Also, we have Redis and MySQL definitions over here, but these are just Kubernetes manifests because I just write these manifests and deploy them directly to Kubernetes. Nothing fancy. Now this entire system already is running on my staging Kubernetes cluster. I'm not going to go into the details of the code, but if you would like to dig into it, it's already published on my GitHub. You can go to Kubernetes, chapter 6, services. And all this code that I just showed you in my IDE already present on my repository. Now, if I make a curl request to my service A, the complex request API, I get the response back, the contents of the file, environment host, whose value is Kubernetes pod because it's running inside the Kubernetes pod, Redis foo response bar straight from Redis, and the MySQL data response from service B. This is what I get. So this is a realistic scenario where a user request actually translates into a web of requests which travel across multiple components in the microservices to finally give you the actual response. And of course, here the architecture and the code are pretty minimal for the sake of simplicity, but you know that in an actual production environment, this kind of thing gets a lot more complex. And this is what we developers actually have to work with. Now, let's say I want to develop service A, which is one component in a much bigger system. Mirrord will help me develop and test service A locally on my system without having to set up the rest of the system on my laptop. So let's open service A code base and close the rest. Let's say I want to add a new field in the response of the complex request API. Now I want to test this code. Okay, let's start the virtual environment. Cool. Let's download the dependencies of service A, which is just the libraries. Now, let's try to run service A. Okay, so if I try to run service A directly on my computer, it fails because there are certain things it expects which are only present in the Kubernetes pod, in the staging environment, and it can't be reproduced right now on my local. In this particular case, it failed to resolve the DNS name Redis. If the app were running on the staging pod right now, it would have been able to resolve this DNS name Redis because it's available in the network namespace. And since it couldn't get the IP address, it failed to connect to Redis, thereby the application crashed. But I can use Mirrord to run this app as if it were running inside the pod that's actually running staging service A. For that, let's fire up Mirrord. I already have it installed on my local. Okay, so to use mirrord, I use the exec command, which tells mirrord that I need to start an application of my own, right? Towards the end of the command, I also tell mirrord how to run my application. In this case, it's pretty simple, Python 3 app.py. Now, exec takes one important argument, which is the target. Target tells mirrord the pod or the deployment in whose context to run my application, right? This is very important. So in this case, I want the pod to be the one which is running service A on staging. So let's get that pod. Here. So this is my staging cluster, and as you can see, MySQL, Redis, service A, service B, everything is deployed. I want service A pod. So let's specify service A pod and run mirrord. So now the application runs successfully on port 5000. This time the app was also able to resolve the DNS name Redis into an IP address, and it was able to connect to it because it is running in the context of the staging pod. Let's make a request to the app. Complex request and JQ for readability. Perfect. We got the response, and I can also see that the new field I added, the code changes I made, are now reflecting in my request's response, right? So even though application A is running locally and all the other services like Redis, service B, they are running in the remote staging pod, my app A was still able to talk to them and get back a response. Now, by default, mirrord mirrors all the requests from staging into our local app. What that means is, if I send any requests to application A on the staging cluster, if I have a mirrord connection with it, then those requests will also land on my local application. And both these apps handle these requests. But of course, the response to the client is ultimately returned by the staging app, and the response created by the local app is discarded. But nevertheless, this is how mirrord mirrors the traffic. So if I make a request to the staging app now just keep in mind that I am currently streaming the logs of my local app. Let's go make a request to my staging app. Boom. Notice two things. Thing number one is that when I made a request to my staging app, right? That request also landed on my local application for handling. Okay. Number two, notice that this request's response does not have the new field that I added. Why? Because this new code change is not deployed to my staging application, and this response came from staging. So staging cannot give me that new response. So it's fine. It doesn't break anything for me. Whilst my local app does give me the new response, and it also receives all the requests that staging receives. And it's not just my requests, anybody who makes requests to staging, everything goes. This is also one of the key differences between mirrord and telepresence. Mirrord supports traffic mirroring, but telepresence doesn't. But my favorite part about all of this was that I made some code changes to my local application, and instantly, without any CI/CD involved, without deploying to staging or any other test environments, I could just fire up a tool and instantly try out my code changes right here on my local without having to set up anything else. And it did not cost me a thing. Pretty cool, huh? By the way, I keep saying staging cluster. That's because I'm using mirrord to connect to the staging cluster over here, right? But technically, it doesn't have to be staging cluster because mirrord allows you to connect to any kind of Kubernetes cluster, which means potentially you could also be testing your local app directly in the context of a production pod. But do you really want to do that just because you can do that? I leave that judgment up to you. All right, let's go to something even more interesting. By default, mirrord will just mirror all the traffic, right? Once it is running, any request I send to the remote pod also comes to my local app. But what if I want to segregate the traffic? What if I want some specific requests to land on my local app for testing purposes, and all the other requests can just go to the staging app as always? For example, Say I'm implementing a breaking change in my application. Instead of calling the API complex request, I'm now going to call it very complex request. Let's make that change. Now, I don't want all the traffic going to the staging app to be mirrored because that will cause a lot of errors because I just renamed my API. Instead, I want all the requests to continue going to staging just as normal. But whenever I make an API request with a new path, which is very complex request, I want this request to only go to my local app for handling and not to staging. So this way I've segregated the requests. Some of them only go to my local, some of them only go to staging, and they are handled separately. This is called traffic stealing because I'm stealing some part of the traffic which was originally meant for the staging app, but instead now it will be handled by my local app. So to configure traffic stealing in Mirrord, you actually have to write some small JSON configurations for it. Let's start by writing the simplest configuration, which will steal all the traffic. Cool. Any request that goes to staging will get forwarded to my local application, and no request is actually handled by staging, right? So this is a pretty disruptive configuration, but for the demo purposes, I'm feeling a bit adventurous. Now, I moved the steal traffic configuration inside service A directory just for ease. Okay, so I will use the same mirrord exec command that I used previously with one additional parameter. Yeah, so I do -f and supply the configuration file that I want mirrord to use while running my current application, right? And since this steal all traffic JSON simply tells mirrord to steal all the traffic, we'll see how that goes. Okay, application running once more on my local. Just to make sure things are working fine, let's make a request. Yeah. So since I have changed the API path, if I try to make a complex request, API request, it gives me a 404, path not found, which means if I send a very complex request, that gives me the data. Cool. So once again, the changes reflect on my local. Good. Now that I know that the local is running fine, what I want to do is run another request to my staging. And this time the staging will not give me a response. The response will come from local because all the traffic is being stolen and given to my local. So let's see that. Curl staging complex request. Okay, if I send a complex request, yeah, to JQ, it gives me a 404, which sounds about right because my request got forwarded to my local app. And if I give a very complex request, it gets handled, which means all the traffic stolen and given to my local app. So that's the most basic traffic stealing, which is steal all the traffic from staging. But of course, this is not what we want ideally. I only want to steal a subset of the traffic and send it to my local. The rest should just be handled by staging. So let's see how to do that. In the app again. Traffic, I'm also going to rename. Steal some traffic. Pretty good name. I'm going to filter my requests based on a specific HTTP header, right? What I'm going to say is if a request has a specific header in its HTTP request, then forward this request to my local application. Otherwise, by default, keep sending the request to the staging app. This is where I specify my header. Cool. So now I'm telling Mirrord that if any HTTP request arrives with this specific header, xtester, then you steal the traffic and send it to my local. Otherwise, let staging handle it. Let's roll it out. Instead of steal all traffic, I'm gonna say steal some traffic. Okay, application running once more. Once again, I want to do a localhost test where I send a complex request. Okay, invalid because this API does not exist on local. Very complex request does exist, so it gives me the data, all good. Querying staging. And if I send a complex request, okay. So this time when I send a curl to my staging with complex request API, it should give me a proper response because traffic stealing is not expected here right now because I'm not supplying any headers. Good, it works. Now, if I specify my header, okay, the exact header and its value, xtester Raghav. If I specify this header, then this request should be stolen and sent to the local application. And it did. With just this header, it got sent to my local application. I got the log here and it sent back a 404. And now this request will be able to handle very complex request, right? But if I didn't specify the header, for example, then the request would have landed on staging and staging doesn't know what to do with this request. Right here, right? Now, notice one more thing. It has to be this exact header with this exact value. If let's say I get the value wrong, this request will still go to staging. It won't go to my local application. The beauty of it is, if I make any breaking changes in my code locally, I don't need to deploy those breaking changes to staging. I could just test them out on my local until I'm sure that everything's good. And then I have a plan on rolling out the breaking changes. I don't break anything on staging, so I don't break anything for anybody else. But at the same time, I also test thoroughly. And of course, Mirrord's traffic stealing can work with many other different kind of parameters. Header was just one example that I gave you. But for example, you could also filter out on specific API paths. There's a variety of examples on the docs if you want to go and check it out. Now, here is an interesting question. How can multiple developers simultaneously test their own code changes using Mirrord? In other words, can your entire team share one staging deployment to test their changes without interfering with each other's tests? Mirrord has a paid feature which does exactly this. If you buy the Teams license, it enables multiple concurrent sessions. Of course, if you're developing alone, you don't need a Teams license. But when you have a larger team collaborating with each other and your system gets more complex, the features provided by the Teams license become a lot more valuable. Now, once you get a Teams license, you also need to install the Mirrord operator on your Kubernetes cluster. Okay, I don't think I'm going to find it like this. So let's try this command out. Mirrord operator setup. Now I need to supply my license key. Let me go and grab my license key. This is what your Mirror-D dashboard would look like. Okay, it looks like my operator got installed. And I can run get deployments. Yep, okay, sounds good. So now I have Mirror-D operator installed on my Kubernetes cluster. This operator will now help me manage all my concurrent sessions, security, RBAC, everything that the ops team needs. Full package. Cool, so now I've got two different systems. Let's say two developers are developing service A on both these computers. On the first system, the test field should say hello from system X. So just to confirm that this is the only change we've made, let's do a git diff. Okay, so this is the only code change we've made to the system. Also, this system is connected to the staging Kubernetes cluster and can see the remote pods. Good. Everything is in order on the first system. Let's run the app. And now if I make a request to the app, I should see my code changes on the system. Yep, test field, hello from system X, which means developer 1 on this system is able to test their code changes locally. Now, while the app is running on this system, let's go to the second system and do the same drill. This system is also connected to the same staging Kubernetes cluster, and we're going to use the same service A pod with Mirror-D to test changes. On this one, the test field says hello from system Y. Let's run the app here. Same pod. Okay, and we are running. Yep, test field, hello from system Y. Perfect. I make a request on X, my response contains hello from system X. And if I make the same request on Y, the response contains hello from system Y. This way, multiple developers can plug their local app into the same remote pod and share it. You don't need to deploy the service on multiple clusters and nobody is going to interfere with your testing. Because now the multiple sessions are managed by the central Mirror-D operator I installed. Now, concurrent sessions is not the only feature that a team's license gives you. It provides RBAC, which allows your ops team to control who has permissions to use which targets. And so far, I've only mirrored a single pod. If you want to mirror all the traffic across all the pods in a deployment, Teams license makes it possible. But of course, all this is only useful if you have a larger team working on a complex system. If you're developing a single app all by yourself, Mirror-D is still going to be super useful, but you don't need the paid features just yet. But all in all, this workflow makes life so much simpler. But of course, like all things in engineering, all this simplicity does come with some potential complexities too. You might find yourself fighting networking or proxying issues every once in a while because you're not able to talk to your apps, and now you don't know if the problem is with Mirrord or with your networking stack. Also, running Mirrord in your infrastructure introduces some additional overhead for your ops team because now they have to manage access control for it and oversee the operator installed in Kubernetes clusters. The good part is that Mirrord's documentation is in a really good state, and they also have a thriving community on Discord, which is always willing to help people out. But at the end of the day, I consider these trade-offs to be worth it because I save my time, my company saves money, and overall the management overhead for the ops team is actually going down. Telepresence is yet another tool in this space that greatly simplifies your local app development. If you've tried it out, let me know in the comments how your experience was and how is it different from Mirrord. In conclusion, all I want to say is that if you are developing microservice applications on Kubernetes, chances are that you will greatly benefit from this new paradigm of local software development. It's faster, it's cheaper, it's not for everyone, but Mirrord is definitely worth a shot. If you found my video insightful, give it a like. Subscribe if you're new here. These things allow me to keep creating valuable content on software and DevOps for the entire community. See you next time.